When solving equations, typically you have a value of x as your solution, but this is two more situations that may occur. One of them is infinitely many solutions, and the other is no solution. All right, here we go. Solve for x. 2x is equal to 10. We are going to start with a very simple problem here. We're going to do simple things to understand complicated things, but we're really going to understand what we're doing here. So I'm going to, off to the side here, I'm going to solve this, okay? And x is equal to 5, right? And so what does that mean? X is equal to 5. Well, if I come back into the original problem here and I replace that x with 5, right? I just replaced x now with a 5. Everything else stayed the same. We get 10 equals 10, and that is true, right? Okay. So this is our solution, right? And this is me verifying that that actually is true. And I'm going to say anything else would not work. Like, let's say you tried, I don't know, 6. 2 times 6 is equal to 10. Look at how we're getting 12 is equal to 10. That's false, right? We could make up any other number we could try. And I'll just make something up. So I'll just say -3. 2 times -3 equals 10. -6 equals 10. That's false, right? Those two quantities are not equal. So guess what? I could go on and on and on and on and on and on. I could try any other value I want x to be. I can make it up. As a matter of fact, infinitely many numbers. I just tried 6 here, got a false. I tried -3 here, got false. I could try any number you could think of in the world. I could try any number and it will always be false except for this one value of 5, right? So this means that we have one solution, okay? And I know you might be thinking this dude's a little crazy right now because why is he going out of his way to say all this? But we have to understand what one solution means, right? One solution means that there's only one value that will produce a true statement if you go plug that value into the original problem. Everything else is producing false statements here, okay? Let's go to the next one. So let's check this out. Now we're on example 2, and this is where things are going to get a little funny. Let's just fake like we don't know. We're just solving it, and we get 6x plus 3 is equal to 6x plus 3. As soon as you see this, you should be like, whoa, like what? Like this should be a little like alarming to you, right? Like this is equal to this. Okay, because obviously if I subtract 6x from both sides, the 6x's are going to disappear and we get 3 equals 3. But let's just look at this, okay? Let's say we had this, and I'm going to stop us here and I'm going to say, okay, I'm going to go out on a limb here. I'm going to say, look at any value of x you plug in is going to produce a true statement, okay? I'll just make up a number. I'll just say x equals 7. Let's check x equals 7. Let's check it, okay? So if I go and I replace x as 7, boom. Look at that. True. Let's check another one. Let's say that we had x is equal to -2. Look at that. Another true statement, right? We're replacing x with -2, and we get another true statement. Let's make up another one. Let's say x were equal to, I don't know, 4. Once again, look at that. Another true statement. Guess what? I could use any number I want, right? I could try -100. Look at that. It's true again, right? I could choose any number I want, right? And so in this case, what's happening is that literally all values of x are producing true statements, which means that every number you can think of, fractions, decimals, all these things, you plug them in, you replace x with that value, guess what? You got yourself a true statement. Okay, so whenever you get in this kind of a situation, and watch what's going to happen. So, because I'm gonna make this. We're gonna like generalize things in a little bit. Watch what I'm gonna do. So if you get in a weird situation like this, do me a favor. I'm gonna tell you, get those variables to cancel out, okay, and see what you're left with. if you're left with something that is true, always those x values are going to be able to cancel out. Whatever you replace x with, they're going to cancel each other out. And either you're left with a true statement or a false statement. If you're left with a true statement, then any value of x you plug in will work. And so there are infinitely many solutions. And so we write that. Infinitely many solutions. I don't know. Some people put IMS. But that's what it means to have infinitely many solutions. Every value of x that we were to plug back in, they're going to work. We're going to be left with a true statement. Okay, so here is our last example. And check this one out. We're going to solve it just like normal. Okay. Hopefully you're able to notice, like, that looks a little weird, right? Let's continue. Let's try to get those variables to cancel out. So anytime you get in a situation in math where you can get the variables to cancel out on both sides like that, let them go. And look what happens. We're left with, this time, a false statement, right? And so what I'm going to tell you, when you get rid of those variables and you're left with something that is false, right? We're going to say that there is no solution. And you could either write this, or you can just write no solution, and they're both acceptable. So what's happening here? Well, let's go check. Let's look back at, let's come back to this right here when we were at this. Let's just let x be random numbers. Let's let x be 1. Look at that. 9. So 6 plus 3 is 6 plus 4. That's not true, right? Then we get 9 equals 10. And that's false. Let's let x equal 2. Again, that's false. Let x equal 3. This is, do you see how this side is always going to be 1 more than this side, right? Look at how we're getting 21 is equal to 22. And again, it's false, right? So look at the pattern. We can continue on and on. This was not a solution, not a solution, not a solution. I guarantee you this is not going to be a solution. And guess what? Forever and ever and ever, it's never going to be a solution. This side, according to what we see here, this side will always be 1 more. They're always going to be off, and there is no solution. Okay, so if we go back to that original problem here, this was the original problem. They asked us to solve for x here, and we distributed, and we saw that we had the x's were able to cancel out, and we were left with a false statement. So this is the situation in example 3. This is where you have no solution. Okay, and so now what we need to do is just generalize our 3 different scenarios, okay? Because every time you're going to be in one of the 3 scenarios. What are the 3 scenarios here? Let's write them down. The first one is when we have one solution, and this is where we have something like x equals a number, or we have a number equal to x, right? And the next one, and this is the one that most likely, like 99% of the time, this is what the scenario you're in, right? But then sometimes you get in a situation where you have infinitely many solutions. And remember, I told you to get those, if you can get those x's to cancel out, go ahead and let them cancel out on both sides. So if those x's are able to cancel out, and then you're left with a true statement, this is where we say infinitely many solutions as our answer, okay? And our last situation is where we have no solution. And again, we always try to get, if possible, get those x's can cancel out. But this time we're left with a false statement, right? And again, this is where no matter what value of x you plug in, they're canceling out, or you're just left with something that you have a false statement, right? That's what you're left with when you get those answers. You could plug in any value you want, and they're all coming out to be false, right? If you wanted to check, this is where we have no solution as our final answer, or you could just write it like that, right? It's like a 0 with a slash through it. Okay, so this concludes our discussion on the 3 different scenarios that exist when solving for x. I'll see you in the next one.